Okay, so you want to own an indoor vertical farm. You buy a warehouse on the outskirts of the city, stack automated hydroponic trays 20 feet into the air, flip on some purple LED lights, and watch pesticide-free, gourmet baby greens grow on pure computer automation, while you sell $3 bags of butterhead lettuce to Whole Foods and high-end restaurants. It feels clean. It feels tech-enabled. It feels like you are printing crisp green bills out of thin air. Globally, the indoor vertical farming market is rocketing toward a $17 billion valuation, driven by a projected annual growth rate of over 24%. In the United States alone, the industry consumes more than 3 million square feet of automated growing canopy, fueled by hundreds of millions of dollars in venture funding. But here is the number that should keep you awake at night. Over the last 48 months, more than half of the venture-backed vertical farming mega-facilities that raised $50 million or more have either entered Chapter 11 bankruptcy, shuttered massive flagship facilities, or liquidated their custom automation assets for pennies on the dollar. Companies like AeroFarms, AppHarvest, and InFarm raised hundreds of millions to disrupt traditional farming, only to discover that plants do not care about software valuations. That is the paradox. The consumer demand for ultra-clean, locally grown, hyper-fresh produce is at an all-time high. But the underlying operational physics of turning electricity into edible calories is one of the most unforgiving economic models in the commercial world. Understand the brutal math of kilowatt hours per gram of biomass, and you understand this business. Miss it, and you will go bankrupt owning one of the cleanest, most technologically advanced facilities in your entire state. To understand why this industry exists and why capital keeps pouring into it despite the wreckage, you have to look at the macro vulnerabilities of modern agriculture. In 2026, outdoor commercial farming is under relentless structural pressure. Over 85% of the fresh, leafy greens consumed in North America originate from two hyper-consolidated regions: the Salinas Valley in California during the summer and the Yuma region in Arizona during the winter. When a severe atmospheric river floods California, or when an ongoing drought chokes the Colorado River basin, the entire continent's supply chain fractures overnight. Add recurring outbreaks of E. coli tied to agricultural runoff, and the systemic risk becomes undeniable. The real customer of a vertical farm is not the urban hipster looking for a microgreen garnish. The real customer is the regional supermarket chain category buyer and the institutional food service distributor. These buyers operate on precision logistics. They hate volatility. If a traditional field farm delivers 20,000 cases of romaine that spoils 3 days early because of heat stress during transport, the grocery chain eats that loss. A vertical farm offers them absolute predictability: identical weight, zero pesticides, zero insect fragments, zero wash requirements, and an extra 7 to 10 days of retail shelf life because the product only traveled 15 miles instead of 1,500 miles. That predictability allows operators to command a 20 to 40% retail price premium. But having market demand does not mean every vertical farming business model makes sense, because not all indoor farming operations are the same business. In fact, if you lump them all together, you are making a fatal mistake. There are 4 distinct segments in this market, each with wildly different margins and capital profiles. First, you have the industrial mega warehouse operators. These are 50,000 to 150,000 square foot automated giants backed by institutional debt and equity. They deploy multi-tier robotic racking systems, fully automated seeding to packaging lines, and custom HVAC architectures. They run on gross margins around 35 to 40%, but their depreciation schedules, high utility loads, and massive debt service drag their net margins down into the negative 10 to positive 5% range. They live and die purely on retail volume and national grocery contracts. Second, you have the mid-sized regional commercial facility, typically 20,000 to 40,000 square feet. These operators rely on semi-automated racking systems, off-the-shelf commercial LED fixtures, and hybrid mechanical harvesting. Their gross margins hover around 45%, and with tight operational management, they can deliver steady net margins between 8 and 14%. They target regional grocers within a 150-mile radius and high-volume corporate food service contracts. Third, you have the decentralized container and modular pod model. These are self-contained shipping containers placed directly behind restaurants, college campuses, or urban retail centers. The capital cost per square foot of canopy is astronomically high, running $600 to $900 per square foot. Their net margins are rarely sustainable above 4%, unless the operator uses the container as a marketing tool for a high-end restaurant or sells microgreens directly to consumers at $60 a pound. Fourth, you have specialized culinary microgreen and medicinal crop facilities. These are compact, low-automation spaces between 2,000 and 5,000 square feet, focused strictly on culinary microgreens, specialty edible flowers, or functional botanicals. Because these crops sell for $40 to $70 per pound and have rapid 7 to 10-day crop cycles, these niche operators can hit gross margins above 65% and net margins north of 22%, though their total market size is capped by local culinary demand. When you strip away the stainless steel and the purple glow, the core mechanics of an indoor vertical farm are dead simple. You buy high-grade seed, water, and electricity. You manipulate photons, humidity, and nutrient salts inside a sealed box to convert that electricity into plant tissue. Then you package and sell that tissue by the ounce before it degrades. In this business, there is one single metric that rules over every other operational variable: your electrical conversion efficiency, specifically measured as kilowatt-hours consumed per kilogram of marketable yield. Everything else, your labor automation, your seed germination rate, your packaging speed, is secondary. Why? Because in outdoor farming, the sun is free. In an indoor vertical farm, you are replacing the sun with commercial utility meters that tick 24 hours a day, 7 days a week. Let us walk through the real-world math so you can see how this lever dictates survival. Imagine you operate a 30,000 square foot facility with 15,000 square feet of actual stacked canopy. You are growing premium butterhead lettuce. Your facility produces 600,000 pounds of packaged lettuce per year. You sell that lettuce wholesale to regional grocery distributors for $2.75 per pound, generating $1,650,000 in gross annual revenue. Your fixed overhead, including warehouse lease payments, equipment lease amortization, facility insurance, administrative salaries, and baseline environmental maintenance, sits at $620,000 a year. That bill does not change whether your lights are running at full blast or completely switched off. Now, look at your variable energy cost. In your target market, your commercial industrial electricity rate is 12 cents per kilowatt hour. If your lighting and HVAC systems are dialed in with modern high-efficiency fixtures and optimal vapor pressure deficit control, your facility requires 8 kilowatt hours of total power for lighting, chilling, dehumidification, and water pumping to produce 1 pound of finished packaged lettuce. At 8 kilowatt hours per pound, your power cost is 96 cents per pound. For 600,000 pounds, your annual energy bill is $576,000. Add in seed, nutrient inputs, packaging materials, and floor labor at 75 cents per pound, or $450,000. Let us tally that up. $1,650,000 in revenue minus $620,000 in fixed overhead minus $450,000 in packaging, inputs, and labor minus $576,000 in electricity leaves you with an operating profit of $4,000. You are essentially breaking even. Now watch what happens when you optimize your photon delivery and HVAC recovery to drop your energy consumption down to 6 kilowatt hours per pound. Your power cost drops from 96 cents to 72 cents per pound. That seemingly modest 25% improvement in electrical efficiency cuts your annual power bill by $144,000. Because your fixed costs and input costs remained completely flat, that entire $144,000 falls directly to your bottom line. Suddenly, your profit jumps from break-even to nearly $150,000. Conversely, if local utility rates spike by 3 cents per kilowatt hour, or if your cooling chillers are poorly insulated and your consumption rises to 10 kilowatt hours per pound, you are instantly burning over $140,000 in pure cash losses every single year. The marginal efficiency of your power draw is literally the difference between a viable business and financial liquidation. So what does it actually take to get into this space in 2026? You do not start with plants. You start with electrical engineering and commercial zoning. The ideal location is a light industrial warehouse with minimum 24-foot clear ceiling heights, reinforced concrete floor slabs rated for heavy vertical loads, and multiple commercial loading docks. But the true gatekeeper is electrical service capacity. A 30,000 square foot high-density facility requires a minimum of 1.5 to 2.5 megawatts of dedicated three-phase power. If you find a cheap industrial building that only has a 400 amp service, upgrading that transformer and running new feeder lines from the local utility substation can easily cost $400,000 to $800,000 and take 12 to 18 months in utility backlog approvals. Then you run headfirst into the bureaucratic hurdles that blindside almost every newcomer. First is wastewater discharge permitting. Even though vertical farms recirculate up to 95% of their irrigation water, the periodic flushing of spent nutrient solutions containing concentrated nitrates and phosphates is heavily regulated by local municipal water authorities. If your city does not allow direct discharge of agricultural effluent into standard municipal sewers, you will be forced to install an on-site reverse osmosis treatment system costing an extra $75,000. Second is cleanroom and agricultural food safety certification. To sell to mainstream grocery chains, you cannot just say your produce is clean. You must pass third-party audits for USDA, Good Agricultural Practices, and Global Food Safety Initiative standards like SQF or BRCGS. These certifications dictate everything from epoxy floor coatings and positive pressure cleanroom airlocks to strict pest exclusion zones and employee sanitary protocols. Failing a single audit will lock you out of commercial supermarket supply chains for an entire buying season. Let us build a full, realistic startup budget for a competitive, mid-sized commercial operation. We are building a 30,000 square foot facility with 16,000 square feet of 4-tier active vertical growing canopy, capable of producing roughly 650,000 pounds of leafy greens and herbs annually. Your core physical build-out begins with facility leasehold improvements, insulating the building envelope with food-grade insulated metal panels, pouring drainage channels, applying antimicrobial flooring coatings, and constructing packaging cleanrooms. That will run approximately $1,200,000. Next is your electrical and mechanical infrastructure. Bringing in a 2-megawatt service drop, installing backup generators, and building an industrial HVAC and dehumidification system capable of removing hundreds of gallons of transpired moisture from the air every single hour. That comes in at $1,450,000. Your automated vertical farming equipment, including modular racking towers, LED grow lighting with precision spectrum controls, automated fertigation dosing skids, and continuous water sterilization loops, costs $2,100,000. Then comes post-harvest automation, optical sorting tables, automated wash flumes, centrifugal spin dryers, clamshell packaging machines, and cold storage walk-in coolers. Budget, $650,000. Do not forget the overlooked soft costs that drain cash before your first seed germinates. Architectural engineering and MEP design stamps at $120,000. Local building, water, and environmental permitting at $65,000. Food safety certification and initial consulting at $40,000. Working capital reserves to cover your first 6 months of electrical bills, initial packaging materials, seed inventory, and technician payroll before accounts receivable start paying out at $600,000. Your total initial capital requirement sits at $6,225,000. Now for the revenue and profitability reality check. Assuming your operational launch goes smoothly, your revenue will ramp over 12 to 18 months. At full production capacity, a 30,000 square foot facility optimized for a mix of 80% premium packaged greens at $2.75 per pound and 20% specialty, culinary herbs at $9 per pound will generate roughly $2,600,000 in annual gross revenue. Against that revenue, your annual cost structure breaks down steadily. Utility power for lighting, chilling, and airflow, $680,000. Direct operating labor, including facility managers, agricultural technicians, and packaging staff, $520,000. Raw materials, including specialty seeds, rock wool or peat plugs, nutrient salts, and branded packaging clamshells, $310,000. Facility lease payments on 30,000 square feet of industrial space at $14 per square foot, $420,000. Insurance, maintenance reserves, testing, and distribution logistics, $210,000. That leaves you with an annual earnings before interest, taxes, and depreciation of $460,000, representing an operating margin of roughly 17.7%. On a $6.2 million initial capital expenditure, your unleveraged cash-on-cash payback period is approximately 13 to 14 years. If you secure state agricultural grants or energy efficiency utility rebates that shave 20% off your capital costs, you can compress that payback timeline down to 9 to 11 years. Compare that to the dream sold by the venture-backed titans. Those companies promised tech industry margins, 60 to 70% gross margins, by building fully robotic $60 million factories that eliminated nearly all human labor. But what they failed to account for was that the capital depreciation and mechanical maintenance on robotic harvesting cranes and specialized computer vision sorters cost far more per pound of lettuce than paying skilled agricultural workers $16 an hour. When you finance a $60 million facility with debt, the interest payments alone wipe out every penny of operational savings. The independent operator who builds a lean, semi-automated system focused on high-efficiency standard equipment and local distribution networks will consistently outperform the over-engineered mega-facility on unit economics. However, you must be ruthlessly honest about the risks that can destroy this business overnight. The first risk is power pricing volatility. Because energy makes up over 25% of your entire operating budget, entering a non-fixed or floating industrial power contract can be lethal. If summer heat waves trigger grid capacity charges that spike your power rates from 12 cents to 22 cents per kilowatt hour, your entire annual operating margin evaporates in 90 days. The second risk is facility biological contamination. The fantasy of vertical farming is that being indoors eliminates pests and disease. The reality is that an indoor farm is a biological incubator. If Pythium root rot enters your closed-loop irrigation system, or if thrips or fungus gnats hitchhike into your growing room on an employee's clothing, they have no natural predators and access to ideal temperature and humidity 365 days a year. An unchecked pathogen can wipe out your entire canopy in 72 hours, forcing a complete mechanical shutdown, bleaching of the facility, and weeks of zero revenue. The third risk is commercial buyer concentration. If 3 regional grocery accounts represent 70% of your total production volume, you are at their mercy. If a major national supermarket chain changes its regional produce buyer, or if an outdoor growing conglomerate slashes conventional lettuce prices to clear inventory, you will face intense pressure to discount your wholesale prices. If your sales price drops by just 30 cents a pound, your operating profit drops by more than 40%. So, what is the final verdict? Should you actually build or buy an indoor vertical farm? This business is not for tech hobbyists looking for passive investment returns, nor is it for traditional field farmers who rely on intuition and open soil. This is fundamentally a high-precision chemical and industrial process engineering business. It is built for seasoned operational executives, mechanical engineers, and commercial supply chain operators who understand facility maintenance, automation controls, and power negotiations, and who possess the patient, deep capital required to absorb high initial build-out costs. If you are entering this space with less than $2 million in capital, or if you plan to rely entirely on automated third-party software while outsourcing your mechanical maintenance, stay as far away as possible. The bankruptcy courts are littered with operators who treated biology like a software application. Indoor vertical farming will undoubtedly play a critical role in the future of food security and modern supply chains. But the operators who survive and build lasting wealth will not be the ones with the flashiest marketing or the highest venture valuations. They will be the quiet operators who master the unglamorous engineering math of converting kilowatt hours into profitable local biomass. Understand that calculation down to the cent, and you can build a resilient, multi-million-dollar agricultural fortress. Miss it, and the lights will go out on your balance sheet faster than you can harvest a single leaf. If you got value out of this deep dive into the real numbers behind indoor vertical farming, make sure to hit the like button, subscribe to the channel, and turn on notifications so you never miss our next breakdown on the true economics of owning a business. Drop a comment below letting us know which industry you want us to dissect next, and thank you for watching.